Great.
Where does AVB and companies like Aviom and Dante and RockNet, I mean, where do they fit into this picture? Are they in this family, or are they sort of to the side of it? Or are they, what's the relationship between those kinds of systems and what you
You're talking about the services that interconnect facilities, or
like Aviom, for instance, has a networking system. They have a stage box. They're sending
devices.
audio over
Right.
Ethernet. I don't know if it's IP off the top
Right.
of my head. I'm just wondering. And then there's AVB, which
Right.
is this new standard. I just broadly speaking, how do they look in the context of what you've been describing here? Are they part of this, or are they aside from it?
Right. If that didn't come through, asking about other kinds of stage box networking, networked audio kinds of systems. Those are essentially competitors to this, but they typically take a more vertical market niche, whereas this is a little broader in the sense that, well, for example, this particular Axia, Wheatstone, Logitech, a couple of other companies, Harris even, although they don't use a very IP standards based, they're using a little more proprietary, but still networked audio. Those are really targeting the radio and to some extent television audio broadcast markets. Aviom, ABB, they're looking at more of the other either post or live reinforcement markets. There's a few companies, there's one company in Australia that's really focused on the facility, like theater kind of, so those are all little sort of sub-verticals, but obviously there's advantages of at least the concept of a serialized networking arrangement, both in terms of, cable count, installation, and scalability. And then, of course, the cost advantages that come along with that. So there's plenty of room, I think, for a lot of different companies. But just in terms of how they fit, I would say they're, with not a lot of overlap, they're competitors. But they're each sort of trying to carve out their market niches at this point. And some of them use, as we said, more or less of a standards basis. Nobody uses, if you could use just the standard, in other words, the internet, you wouldn't need any manufacturer. You basically could build your own, right? But you can't really because of the latency for, these pro applications. So that's why they build on top. Plus, it's the hardware interface question. So that's why you've got companies doing this, but wherever they can, leveraging, some of them particularly like to leverage as much of the standard stuff as possible.
What you've described here is kind of a core technology that each of these manufacturers sort of extends in different ways.
Exactly. Yeah, that's right. You have a core technology that's being extended by, and sort of, putting on the application layer, different stuff, which is much like the internet. When we think of how we're using the internet today, we use it for e-commerce, we use it for streaming, listening to internet radio, watching Hulu, those are all just different applications on this very powerful horizontal technology. Same thing here, it's just a very constrained pro implementation built by people who understand that space or all those spaces, and then just saying, hey, we could use this stuff, as opposed to building it down to the bare metal ourselves. And, off the shelf, even the Pentagon's moving in that direction. So they have other reasons to not want it to be that easy to duplicate what they're doing. But here, as long as you make it secure and robust, and then, user-friendly enough for the folks who have grown up using other, legacy stuff to have it work, and then make the bean counters happy, you're hitting all the right notes there. So, question?
Yeah, you mentioned a few times that there isn't the standardization yet. Would you picture that like there might be the groups get together and kind of do like the mini spec where they get together and make a spec so that way other manufacturers can just adapt that spec to their devices?
Exactly.
For future ability, as you were referring to.
To some extent, that has already happened. It hasn't happened in an SDO, Standards Development Organization, like an AES3 yet. But give the example I'm most familiar with, the Axia company, because they've been doing it the longest, and they have a partnership program they call the Livewire network. In fact, they call their system Livewire, even though Axia Audio is the brand of their equipment. They call the technology Livewire, and there's at least a couple dozen companies that have been licensed into that Livewire environment by the company. So it's still a proprietary space, but you can get a box that's, say, like a digital delay line that broadcasters like to use to be able to dump the caller who swears on the those kinds of tools that people like the specific one, that they want and they're used to, with the big orange button, so the operator can dump the call. For example, there's a couple of those that have Livewire interface. So you don't need a node, you don't need the AES to audio or analog. You just literally plug them in with an Ethernet jack, and they show up on the system. And so that level of interfacing is already available, at least in the proprietary space. What I'd love to see is AES do something like AES-3 that allows competitive companies, not just these what you might call peripheral devices, to talk to the mothership, but literally an Axia in one room and a Wheatstone in another and a Logitech in the third room, all to be able to interface and not have to go back down to AES or to actually talk to each other. So that's coming, but for right now, you still do. There is a fairly flexible level of interop between devices, and I've even seen a Logitech at a trade show. There was one Logitech to Axia where they actually cross-connected between them. And most everything, audio and data, passes through. So that's coming.
Okay. My other question, we were talking about multicast earlier. I assume because it's already in the digital domain at that point, you're not, you're breaking out a single signal to multiple signals. In analog, you're going to get a bunch of gain because you're getting one signal boosting. But because it's digital, you can get one to infinite. It's
packets at that point, and it's just the packets being replicated. The question was, is there anything like what happens in analog when you're splitting or combining signals in terms of level change? I guess that's what you were asking, right? Yeah. Then no, of course. In this case, no, not an issue, right? It's just literally ones and zeros, packets already at that point, and you're just copying the packets as many times as you need, and they're all literally identical copies of each other, and there is no loading to the source that you would think would have to happen in the electrical world. But we're like I said, it's once you get past the physics, it's just math, so.